This progression illustrates a dark universe transforming through a cascade of light. It represents the Bug flare-up theory, a cosmological framework developed by independent researcher Vijay Shankar Sharma. Published at vijayshankarsharma.com, this model provides a mathematical challenge to the established Big Bang model by reimagining the origin of cosmic energy. The James Webb Space Telescope recently identified massive, morphologically mature galaxies where the universe was supposed to be less than 500 million years old. These structures are too complex and too large to have formed within the timeframe allowed by the standard model, suggesting a much longer history of structure formation. Standard cosmology explains universal expansion using the balloon analogy, where galaxies move apart like dots on an inflating surface. But this geometry requires a center. A balloon only expands because a central pressure source pushes outward, providing a specific directionality to the motion. If the universe functioned like an inflating balloon, our instruments would identify that central origin point and the directional force pushing us away from it. Instead, telescopes find an isotrachic cosmos with no detectable center and no observable edge. We frequently observe hundreds of galaxy collisions across the sky. To maintain the theory of universal expansion, these events are classified as local exceptions, where gravity overrides the outward flow of space. However, the model lacks a defined boundary for where these local interactions end and universal expansion begins. When our primary physical analogies fail their own geometric tests, and our most advanced telescopes find ancient structures in a supposedly young universe, the foundational logic of the Big Bang model is under significant pressure. In 1917, Albert Einstein introduced the cosmological constant into his equations for general relativity. His mathematics indicated that the universe was naturally infinite and stable, and the constant represented the energy density required to maintain that equilibrium. 12 years later, he abandoned the constant after Edwin Hubble reported that distant galaxies appeared to be receding. Einstein spent the rest of his life believing this was his biggest blunder, assuming his instinct for a stable universe had been wrong. His original equations were actually correct. In an infinite universe, the gravitational pull from surrounding matter cancels to zero in every direction. The cosmological constant does not represent a repulsive dark energy. It expresses the intrinsic stability of an infinite space-time manifold. Einstein possessed the correct mathematical framework for an eternal universe, but his interpretation of early telescope data led him to discard it, setting the stage for decades of increasingly complex modifications to cosmological theory. A finite universe requires a physical boundary, but any proposed edge to space would itself be in space, with more space on the other side. This logical requirement suggests the cosmos has no terminus in any direction. Since general relativity proves space can warp and transmit waves, it must possess a physical substrate. BFUT names the substrate spaticles. Quantum fluctuations here, deviations allowed by the uncertainty principle, provide a mechanism for matter to arise continuously across infinite time. As matter accumulates gravitationally, it arrives at different angles. These offset trajectories impart net angular momentum, creating rotational motion. Over infinite timescales, objects moving in straight lines collide and are destroyed. Thus, the surviving population consists entirely of stable, rotating, spiral structures. The rotation of every star and galaxy is a predictable result of this selection process. It is the visible evidence of infinite time and continuous gravitational accumulation. During the trillions of years of the pre-ignition era, gravity silently wove hydrogen into a filamentary cosmic web. This invisible loom established the large-scale structure of the universe in total darkness, long before the first star ignited. Eventually, the density of this accumulated matter reached the critical temperature and pressure required for nuclear fusion at multiple locations simultaneously. These first ignitions radiated energy into neighboring dark clouds, pushing them over the fusion threshold and triggering a universal chain reaction. This is the Big Flare-up, a singular event where a universe full of accumulated matter caught fire for the first time. This process describes an ignition of pre-existing matter rather than an expansion of space itself. The unique conditions that allowed this cascade, a universe saturated with fuel that had never experienced fusion, existed once and cannot be repeated. The cosmic microwave background represents the dynamic thermal equilibrium of this ongoing fusion activity. Applying the Stefan-Boltzmann relation to the energy density of all active stars derives the observed temperature of 2.725 Kelvin, with no free parameters or inflation required. Gravitational sorting explains why we see distant galaxies moving away without requiring the expansion of space. This mechanism relies on the natural selection of trajectories over cosmological timescales. Imagine an endless highway where cars move in all directions. Vehicles on collision courses eventually eliminate each other, leaving only the survivors. These surviving vehicles are naturally on divergent paths, moving away from each other simply because those were the only trajectories that allowed them to endure. This simulation demonstrates how Newtonian gravity alone produces Hubble's law. In a sorted population, the fastest-moving survivors have traveled the furthest from their last interaction, creating a statistical correlation between distance and recession velocity that mimics universal expansion. The standard model requires 95% of the universe to be composed of undetected dark matter and dark energy to stay mathematically consistent. This structure relies on 7 interdependent assumptions that have yet to be directly confirmed by experiment. The universe has sorted itself over infinite time into a stable pattern of surviving galaxies. By recognizing this process, physics no longer needs to rely on undetected forces to explain the motion of the stars. The Big Flare-Up theory provides 10 specific falsifiable predictions, ranging from the distribution of matter density in gas clouds to the correlation of CMB anisotropies with star-forming regions. To ensure transparency, the author has provided 7 interactive simulations and open-sourced the code. These tools demonstrate how flat rotation curves and gravitational sorting emerge from confirmed Newtonian physics without any tuned parameters. You can visit vijayshankarsharma.com to download the full academic paper and test these simulations for yourself. By relying on testable predictions and Newtonian dynamics, this framework offers a different path toward understanding the structure of an infinite and eternal cosmos.